Hello everyone, welcome to my Computer Science 318 class. That's a class where we study algorithms and trying to analyze them. If you are not from my 318 class, I'd like to welcome you here as well. If you want to know more about computer science, that's definitely the way to do that. This class, the way I would describe that is we try to analyze algorithms. So we take an algorithm, okay, and we think like how well does it perform. Okay, so for example, if you have an array, right, and you want to sort an array, let's say there are 20 elements or like 1 million elements, and you want all of the elements, all of the numbers there to be in a sorted order, sorted way, okay? There are multiple ways of doing that, and the question is like, which one should you go with, right? Because like if let's say you have, I don't know, 10 elements in the array, you can spend like a fraction of a second. But what if you have a billion elements of the array, right? You can spend like an hour or 2 or 3. Really depends on how you do that. So this class is a mixture of computer science, fun problems from the internet, and maths. Okay, so we take those fun problems from the internet. We're trying to think about how we solve that in computer science, and then trying to analyze that using maths. How quickly does the algorithm run? Okay. So today will be lecture 17. By the way, a couple of announcements. So I'll try to make these lectures as short as possible. Maybe they'll be like 20-30 minutes long, but they'll be packed with information. I will not be deviating to any other topics, especially the job and career search, because on this channel there will be separate videos about the job search. Okay, so that's why these lectures will be they'll be all about computer science 318 and algorithm analysis. Okay. Yeah, if you don't like them, you don't have to watch them at all. In this case, though, I don't think you will be able to understand what I'll be testing you on, because all that information will appear on the quizzes and on the midterm exams, one exam, and in the final exam. Okay. However, you can speed up the video. You can jump to different sections using the time codes below. Right? Yeah. So I'll be typing all of those notes up in Google Doc. I highly recommend you do that as well. Take notes with a piece of paper and a pen, because in this case you will remember the material better, and that's very important for this class, because although it may sound like very easy and clear for you, trust me, when you get to the exam or the quiz, you can get lost easily. Okay, I think that's it. Let's start. So today we're talking about convex hull problem, right? So if you guys don't remember what convex hull, what convex is, what convex hull is, highly recommend you revising that. But the convex hull problem is the problem of constructing the convex hull for a given set of endpoints. I already typed that up. Okay, the convex hull problem is the problem of constructing the convex hull. So you have a set of points, you need to construct a convex hull for that set of points. Hold on. Okay, for a given set S of endpoints. To solve it, we need to find the points that will serve as vertices of the polygon in the question. So basically, let's say we have these points. Okay, I drew them like a very like fat circles, but those are the points. Okay, and we need to construct a convex hull. As you remember, I was advising that like you basically take a ribbon, right, and you kind of wrap that thing around with the rubber band. Okay, so kind of the idea will be this: the convex hull for this particular set of points will look like something like this. Okay. Right. So again, you take a rubber band, you wrap around. So imagine each point is the stick in the ground. Okay. And then you take a rubber band and you wrap that thing around, and where like you see that rubber band, that's where your convex hull will be. Okay. So you're basically gonna have like only the you're not gonna have any angles which point inward, only outwards. Okay, so you're not gonna have anything like this, for instance. Okay, so that's not allowed. That's not convex hull, right? Because again, if you take that rubber band, it will not be, it will not wrap around this stick. Okay, it'll be this. So the question is, if I have a Cartesian plane, right? So let's say I have something like this, and I have this. So that's x, that's y. how, like, and I know a set of those points, how do I know if, like, what points belong to the convex hull? That's the question. Okay. Yeah, so now, since as of now we're talking about the brute force search and like very inexpensive, like inefficient methods of solving problems, right? So I guess the question to you, like, so what do you think? How would you solve that problem? What would you do? So again, you have these points, right? And you kind of need to think about which ones belong to the figure which is creating that outward shape figure. Okay. So as a hint, what if, for example, you take this line, like the line of these 2 points, okay, if you construct a line like this, okay, so you know that this one is that, like, there is a way probably to know, like, if you just like take a look at it visually, right? So can you see that that this line belongs to convex hull? You probably can, right? Because again, so everything, all the other points, they're on one side, and there are no points on the other side. What if I take, for example, these 2 pairs? Let's say this guy and this guy. Well, no, this guy and this guy. Okay. Does that create a convex hull? Well, let's do. Okay, let's say it goes that way. Okay. So the answer is no, right? It doesn't create a convex hull. Like, why? Because if you try to wrap a rubber band around these 2 points, it will actually get into here. It will get stuck here as well. So a way, most intuitive way to solve the problem is the following. If you take any 2 points, draw a line in between, okay? If you have all other points situated on one side, let's say on the left at the bottom, but not on the top, right? In this case, that belongs to the convex hull, and not vice versa. So for example, this line, you see, it kind of splits the whole figure into 2 sets. So everything is on the left, but there is one on the right. This line, though, doesn't. All other points are on the left. There are no other points which are to the right. You see what I'm saying? So that's a way of doing that. So basically, the most intuitive way to solve the problem is if you consider all pairs of points, and if you test where all other points are situated. Are they on one side, or are they on different sides? If they're on different sides, that means that's it. Okay, so you cannot solve that. So that does belong to convex hull. But if they're on the same side, right? So if, let's say in this case they're all on the left, okay, that means that this line belongs to the convex hull. That's the idea. Okay. Okay, so simple but inefficient way to solve this problem is based on the following observation. It's based on the following observation. About the line segments making up the boundary of a convex hull. Okay, so a line segment connecting 2 points, Pi and Pj, of a set of endpoints is a part of the convex hull's boundary. Convex hull boundary. Only if, if all other points of the set lie on the same side of the straight line through these 2 points. Okay, So one more time. A line segment connecting 2 points, Pi and Pj, so there are 2 points, I and j, Pi and Pj, of a set of endpoints, is a part of convex hull if all other points of the set lie on the same side of the straight line. Okay, so again, so if I take, for example, let's say blue, okay, so if I take this line, for instance, okay, if I draw that line, all other points, they all lie to the bottom, none of them on the top, okay, so that's why, so that's the observation, okay, which is going to help us solve that problem, okay. So now, okay, cool, you may be thinking, okay, thank you, but how would I do that? How would I actually know that all other points lie on one side, not the other one, okay? If I only know the coordinates of those points. The answer to this question is geometry. So we need to remember that if we know the coordinates of 2 points, we need to, we can actually draw, like, we can find out what is the equation for the line in between the 2 points, okay? And then using, again, geometry, geometrical equations, we can test where all other points align. Okay. So repeating this test for every pair yields a list of line segments that make up the convex hull. Convex hull's boundary. Hold on. Boundary. Okay. Cool. Okay. So how do we solve it? Okay, so we all know if we have 2 points, then the line between them should comply with the equation of ax plus by is equal to c. Okay. Where where a is equal to y2 minus y1. Okay, so we have 2 points, p1 and p2. Okay, so given 2 points, p, let's say 1, x1, j1, y1, okay, and p2, x2, y2. We know that we have an equation of the line where a is equal to y2 minus y1. Then what else? B is equal to x1 minus x2. Okay, and C equals to x1 y2 minus y1 x2. Okay. So basically, again, if we know coordinates of 2 points, we can construct this line, okay, and then we can test whether all other points located on the same side. So how do we do that? So okay, so that's the first step. So the first step is to get this equation. Okay, second step. Such line divides the plane, Cartesian plane, right, into 2 half planes. For all the points in one of them. Now, and here's something we should need to remember. For all the points of one of them, a times x plus b times y greater than c, okay? While all other points will comply with a times x plus b times y is less than c. Okay, so yeah, so one of them would be like for some points this will be true, for other points this will be true, right? Now if that point, a new point lies exactly on that line, that means this will be equal to c. Okay, so if a point lies on that line, then this will be equal to c. Okay, make sense? Probably not. So let's let me show this to you. Okay, so let's say you have a couple of points. Text. Okay. Okay. So wow, that's so small. Okay, so let's say you have P1. Let's give some real example, like some real values. Let's say, okay, let's say this would be P1, and XY would be, I don't know, X would be, I don't know, 3, and Y would be 8. Let's say this is P2, X would be, I don't know, 5, and Y would be 5. No, 5 would be 7, okay? And let's say we have this point, which is P3, and the coordinates would be 3, 3. No, not 3, 3. 2, 2, 2. Okay? 2, 2. So the question is, if I have a line P1, P2, and P3, so you have a line between P1 and P2, P3, like, is that, well, yeah, so P3, where is that located? On one side or another side? Or let's say, like, if I have another P4, okay, with the another point with the coordinates, let's say 2, 1, okay, yeah. So if I have P1, so let's imagine that all I have, no. No, how would I delete it? I don't wanna. That will take me so long. Okay, so let's imagine that I have only these 4 points. Right, I have a set of only 4 points. Okay. So the question would be, does P1 and P2 belong to convex hull? Right. So the segment of P1 and P2, that line, does belong to convex hull. Okay. So the first thing we need to do, we need to calculate this. We need to calculate. We need to do these calculations. So what do we know? AX plus BY is equal to C. Okay. So what is A? What is A? A is equal to, okay, Y2 minus Y1. Okay. So Y2, 7 minus Y1. Okay, minus 8 is equal to -1. B would be, what is B? B is x1 minus x2. So x1, 3 minus 5 equals -2. Now C equals x1, y2, x1, 3, y2, so 21. Minus y1, x2, so 8 times 5, 40. Okay, so that becomes -19. Okay, so in this case, AX, so the equation would be minus x minus 2y equals minus 19. Okay, or x plus 2y equals 19. Okay, so I hope that's correct. I'm completely improvising. Anyway, the whole idea, the whole point is this though, that we calculated this line, right? So that's the equation of this line, and now we need to plug it into this equation. Okay. In order to understand if P3 and P4 lie on one side or on separate sides, here's what we need to do. We need to we need to plug this 2 into this equation and this 1 into this equation. And if for both of the cases the sign will be the same, like less than, right, or greater than, in this case they're located on one side. So for example, for P3, okay, for P3, P3. 4P3 A. Okay, so -1. So that's our A times X, which is 2, plus B, which is -2. So -2 times Y, which is 2. Okay, and we have question mark C, which is what? -19. Okay, so let's calculate that. So it's -2 minus 4. That's greater than -19, right? Okay, and now 4P4. Again, so A -1 times 4. Sorry, 2, right? X, okay. Plus -2 times Y1 greater than -19. Okay. So what do we have here? -2 minus -2 minus 2. No, hold on. So B was 2. Yeah, okay, yeah. That's still greater than -19. Okay. So you see, for both P3 and P4, this sign is the same. Okay, so that means that P3 and P4, they lie on one side of the line. They lie over here, not over there. If there was a dot over here, okay, if there was this dot, then if you plug the coordinates of this point into that equation, then what's going to happen is that it will be less than C. Okay, does that make sense? So let's say I don't know. Yeah, let's take an example. So let's say it's P5. Okay, so let's say I don't know. It would be 5 and 9. Okay, that's approximately what it looks like. So in this case, let's see, 4P5. Now, what is A? -1 times X, which is 5, minus 2 times, so B is -2, times Y, which is 9, question mark -19, right? So what would that be? So -5 minus 18 is less than -19. Okay, so that means that P3 and P4 lie on one side, but P5 lies on the other side. And if we consider the set of P1, P2, like all of those 5 points, then P1, P2 will not be in the convex hull. But if we don't have P5, right, in this case we see that all other points, P3, P2, P3, P4, they lie on one side, right, not on separate sides. That means P1, P2 belongs to the convex hull. Okay, hope it makes sense. How much time? Okay, cool. So that's how you solve it. That's how you solve it. I hope you'll be able to solve it later for the homework and for the quiz. Okay, so now I want to briefly talk about the next topic, and then we'll wrap up for today. The next topic is exhaustive search. Exhaustive search. Okay. Oh, by the way, hold on, no, we didn't finish this one yet. Hold on. We didn't finish this one yet. Okay, so we need to quickly talk about time efficiency. Okay. Okay, we're not going to analyze it formally. So, but question, so how quick does this algorithm run? So what do you have here? You have, let's say, I don't know, 20 points. So how many pairs of those points you have, right? So that's n times n minus 1. That's how many pairs you have. For each one, so you need to consider each pair, and for each pair, you need to run these calculations. Okay. So basically, the time efficiency would be big of n cubed. sorry. No, okay. I'll write it this way, n cube. So big O of n cube. Okay, why? Okay, because for each n times n minus 1 over 2 pairs, that's how many pairs you have, right? If we exclude the duplicates, n times n minus 1 pairs, okay, so that's what n squared. We may need to find the sign of ax plus by minus c for each, so for every other n minus 2 points. Okay, so again, how many, one more time, how is this, the entire algorithm works? You need to find first off all the points, how many points you have, n times n minus 1 over 2. For each one of them you construct this equation. So this equation is pretty simple to construct. So that's constant time, that's big O of 1. However, for each one of the pair you need to consider all other points, right? So you need to plug in all other points into this, okay, and that's how you get to n cube. That's how you get to. So that's why it's big O of n cube. Okay, cool. So let's finish this lecture now. I hope you guys enjoyed that. I'll see you next time. Bye.